Hello students, this is Karthik, your maths tutor, heartily welcoming you all to Vista's Learning. What is Vista's Learning? Vista's Learning is an online education platform where we strive to deliver quality education for all. So in today's session students, I am going to present you class 12th mathematical topic, the very first chapter called as Relations and Functions. Alright. So in this session, what are your learning outcomes? So this will be your learning outcomes. In this session, we'll be covering these topics: Introduction to Relations and Functions, what is relations, what is functions, relationship between relations and functions, denoting relations, how do we denote relations, and also we are going to see the types of relations. So this is what you are going to learn in this topic. So watch the video until the end. You'll be learning all this outcomes. Alright, going on to the next slide. Okay, starting with the introduction. So what is relation, students? So this chapter is relations and functions, right? So what are functions? We'll see that later. What is relations? Not mathematically. Generally, what do you mean by relations? So there are many relations, right? Like you are related to your dad. So son and dad relationship. You are related to your mom as well. So son and mom relationship. You are related to your uncle, you are related to your aunt, your brother, your sister, and it goes on like that. Correct? So for example, if you are related with your dad, so we'll take one very small example. So son and dad relationship. So what would be the age of son? So for example, let us take 27. And what is the age of the dad? So dad's age will be 54. Correct? So this is relationship number 1. Let us put number 1. Next relationship would be son and mom. Same son. So for son and mom, what we'll write? Son and mom here. So this will be the second relationship. Again, the age of the son is same only. That is 27. And the age of mom, a little bit lesser than that. So let us take 48. Correct? So see this. 27, 48, 27, 54. What is your relationship with your brother? So he'll be younger than you. So these both are elders, right? So you and your brother or sister. So this will be our number 3 relationship. So this would be 27, 22. So all these are relationships. Son's age, dad's age. Okay, son's age and mom's age. Okay, and again the same person's age with his brother or sister. So 27 and 22. So we can keep on writing like this with aunt, with uncle, with grandfather, with grandmother, and it goes on like that, right? So these are all the relationships. In mathematics also, we have some more relations. So for example, let us take P is a number, any real number, and it is greater than Q. Correct? A relationship in mathematics. So P is greater than Q. In the previous one, like how dad was greater than the son, similarly P is greater than Q. Another relationship, X is lesser than Y. So your brother is younger than you. So X is lesser than Y. Sometimes what will happen, A will be equal to B. So you and your friend's age will be same, right? There will be some difference in the months and days, but the years, both will be same. So these are the relationship in maths with the numbers also. So some more relationships, for example, M is parallel to L. So line M is parallel to line L. This is also one of the relationship. Another relationship, M is perpendicular to N. Another relationship where M and N are the lines which are perpendicular to each other. Another relationship, M, N, O. So all the 3 are points and they are collinear. Correct? So these are the relationships in the mathematics. So what we discussed further, like before, that was the relationship in the life between human beings, the relationship between human beings. So these are the relationship between numbers and lines and so on. Okay. Moving on to the next slide, we will see what is relations in mathematics. Okay. So the question here is, what is a relation? And the answer, students, relations is a set of ordered pairs. So what is the meaning of ordered pairs? Ordered pairs are nothing like this. 1, 3, 1, 4, okay, 17, 15, 22, 33, okay. All these are ordered pairs. So basically relations are, they are represented in this form, x, y. Alright. What is x here? X is the domain, and what is y? Y is the range, or it is the output. Okay, so these are the relations. Next, what we are going to see, what is a function? Just clear the board. Okay, so relations, we came to know what are relations. Relations are a set of ordered pairs. Now, what is a function, students? Function is a special kind of relation. Function is also a relation, but there is something special about the function. So what is that special thing about the function? Okay, we are going to see here. For example, students, what I said relations, we'll take an example of those relationship between mom, son, mom, dad and all. So here the son was 27, okay, dad was 54. Next, son was 27, mom was 48, okay, and the same guy with his brother 27 and 22. So what you have to observe here is these things. Okay, these are same. Now what is very special about a function? So what is function, students? Function is a special kind of relation. So what is that special thing? Okay, try to understand. This is very important. So once you get it, okay, and one of the most important parameters in mathematics. Okay, we'll be using functions until we finish. Mainly we'll be using it in calculus. Alright. So we'll discuss about functions. So this is a relation. So about the function now. So students, before we start with functions, I want to just show you this thing. So here we'll be inputting something, okay, and that input will get processed here. After processing, what will happen? The outcome will, we will be getting the outcome. So here let the function or whatever is processing here, let that process be x plus 7. Alright, x plus 7. That is what is process is happening here. Now let us input x there. Okay. Now let us input x as 1. If x is equal to 1, so 1 plus 7 will be what? 8. Correct? Next, let us put x is equal to minus 5. Let us put x is equal to minus 5. So minus 5 plus 7 will be equal to plus 2. Okay, let us put another value of x. Let us put x is equal to 10. So 10, if you input x is equal to 10, 10 plus 7. So this will be how much? 70. So let's just summarize whatever we have written here. 1, 8. Correct? The next would be minus 5, 2. The next would be 10, 70. What are these? These are called as functions. What was before this, students? I'll just write here 27, 54, 27, 48, 27, 22. What are these? These are relations and these are functions. What is the difference, students? Can you spot any difference here in relations and functions? Understand, in relations, x is same. Y values are changing. See, 54, 48, 22. But when we come to functions, if x is equal to 1, then y will be equal to 8. If x is equal to 5, minus 5, y will be equal to plus 2. And if x is equal to 10, y will be equal to 70. If you input this in the place of x now, okay, so 27 plus 7. So we will be getting 27, 34. By any chance, if we input x in this place, like if we input x is equal to 27, is there any chance we'll be getting 54? So here the x values are same. Understand, x values are same. Y values are changing. Here, for each and every x value, there is a unique y value. Now again, if you input x is equal to 1, you will be getting 8 only. You will not be getting 10. So that is the special thing about the function. Which means In other words, I'll tell you now. Whatever we inputted here, okay, whatever we inputted here in this box, this is called as pre-image. Okay. Whatever process was happening in this box, okay, this is called as a function. And whatever output we got here, okay, this is called as codomain. This is called as domain as well. Domain is nothing but input. Codomain is output. And this is also called as image. So now understand. We'll write in the same function x plus 7. Okay. So whatever values you're inputting here, those are called as what? Those are called as pre-image or domain. Whatever process is happening here, this is a function of x. How is it denoted? F of x, like this. And whatever output we are getting here, this is called as codomain or image. Pre-image, image. Domain, codomain, and function. So this is the special thing about the function. So students, relations can have same x values with different y values. So what is relationship called as? So we'll see. Relations are set of ordered pairs, that's all. So it can be like this: 1, 1, 1, 2, 1, 3, 1, 4. All these are relations. Same x values, different y values. But function is not like that. If you input x is equal to 1, and if you get 1, and again if you put x is equal to 1, you will not get 2. So that is the special thing about the functions. I hope you are understanding. So for examples of function, 1, 7. So again, if you input 1, you will be getting 7 only. You will not be getting any other value here. If you are getting any other value, then it is not a function. Understood? If you input 1, you must get 7 only. Same x values will not have two different y values in functions. It will be having different y values. Alright. So image, pre-image, image, and function. We'll go on to the next one. Relationship between relations and functions. So how are relations and functions related? Every relation is not a function. So for example, 1, 1, 1, 2, 1, 3. Are these functions? Are these functions, students? These are not functions. What is the reason? Why are these not functions? Same x value, different y values. That is why it is not a function. It is called as a relation. Okay, every relation is not a function. Okay, this is not a function. Next, but all the functions are relations. All the functions. So what is a function, students? So functions means what again? One x value will have only one y value. Okay, this same x value will not have another value of y. Means every value of x has a unique value of y. Unique. Okay, and the y value is corresponding to x only. So that function box which is getting processed, as we input x, will get processed and there will be an outcome. So an examples for functions, 1, 1, okay, this is fine. So if you write next 2, this will be 3. Next 3, 7. So these are functions. How are we calling them as functions? Each value of x has unique value of y. Each value of x has unique value of y. Each value of x has unique value of y. Understood, students? So this is the relationship between relations and functions. All the relations are not functions, but all the functions are relations. Alright, moving on to the next one. Okay, so there is one small exercise I have put up here. So tell whether each relation defines a function. So is this defining a function? Yes or no, students? So let us check out the domain and codomain. That is nothing but x is domain, y is codomain. So 2, 3, x is 2, y is 3. Alright, this is a function. Minus 5, 8, x is different, y is different. Okay, this is also a function. Next one, 4, 10. This is x, this is y, Both are, means 10 is now nowhere repeating here. So this is also a function. So each value of x is having unique value of y. So we can call L as a function. Okay, moving on to the next one. Minus 3 comma 0 xy. Okay. Minus 1 comma 4. Okay. 1 comma 7. Okay. Now see this. 3 comma 7. Let us take this case here. Okay. So this is the processor, that is nothing but the function. So here what we'll write is, we will write x plus 6. Understood? X plus 6. This is the processor, or this is the function of x. Function of x. Now what are we going to do here? We will input something inside this processor. It will get processed and you will be getting an output. Understood? Now let us input what? Let us input 1. Okay, let us input 1. So 1. What is this 1? That is nothing but equal to x. Now if x is equal to 1, so 1 plus 6 is how much? 7. So we got the value 1 comma 7. Fine. Next you see in the example, here we have 3 comma 7. Means what, students? In the place of x we are inputting 3. Correct? So in this place, now let us put x is equal to 3. Now substitute the value of x in this processor. So 3 plus 6 will be equal to 9. So the output of x is equal to 3 is 9. So what is the function we got? 3 comma 9. 1 comma 7. 3 comma 9. So if you consider this as a function, then this is not a function. Why? Why this is not a function? Because same output we are getting for two different values of x. Understand this. Same output we are getting for two different values of x. This is the reason m is not a function. You see L, 2, 3, minus 5, 8, 4, 10. Different outputs for different inputs. Different input, different output, different input, different output. Same output, different inputs. This is not a function. I hope you are understanding this. Any doubt, students, please do comment in the comment section. Okay, I'll be clarifying that again. Okay, let's move to the last one, n. N is equal to 6 comma 2, input is 6, output is 2, okay, that is fine. Minus 4 comma 4, this is also fine. See this, students, and see this here. You are inputting x is equal to 6. What is the output you got? 2, okay, fine. You are inputting x is equal to 6 and output you are getting as 5 again. So let us draw this, okay. So what is the function? Let us assume the function here is x minus 4. Understood? So let us input x here now. What is x equal to? X is equal to 6. Correct? X is equal to 6. So when you input x is equal to 6, 6 minus 4 is equal to how much? 6 minus 4 is equal to 2. So output, what did we get the output? 2. What is the function we can write here now? 6 comma 2. Okay, fine. This is correct. See the last one here. We are again inputting 6, but this time we are getting the output as 5. Is that possible? This is not possible. So therefore it is a relation. It is not a function. This is not a function. Only this one is a function. Students, understood? I hope you're getting it. So this is a very small exercise. Okay, here we can tell which are relations and which are functions. I have explained each one of them here. Moving on to the next slide. Yeah, so this is denoting functions with the help of mapping. Alright. So again, this is called as what? X values. These are called as y values, x comma y. So what is the first? See, for if you put x is equal to 1, what is y you are getting? 2. So let us write 1 comma 2. Moving on to the next one. If you put x is equal to 3, you will be getting y is equal to 5. Minus 3 comma 5. This is also 5. If you put x is equal to 4, you will be getting y is equal to 3. So this is nothing but 4 comma 3. Each value of x has only one value of y. and y values are not repeating for the same values of x. So therefore, this is a function. Okay, let us put a tick mark. Okay, moving on to the next image, students, on my left side. If you put x is equal to -1, you are getting y is equal to 6. That is fine. Okay, so we can write -1 comma 6. This is correct. You see the next one here. If you put x is equal to -2, you are getting y is equal to 6 again. Is this possible, students? Same output, two different inputs. This is not possible. So this is not a function, correct? So if you input x is equal to -2, how can you get 6 again? Because you are getting 6 when you put x is equal to -1, right? So again, if you want me to draw the box here, so the box will be something like this. Okay, so here the box will be 5 minus x. Okay, this will be inside the processor, or this is nothing but called as function of x. Now let us input the values of x here. So this is our input and this will be our output. So put x is equal to -1. So 5 minus of -1 will be 6, correct? So we got -1 comma 6. This is right. Now you input x is equal to -2, students. If you input x is equal to -2, what will happen? 5 minus of -2. We will be getting 7. What is the mapping showing? We are getting 6, which means this is not a function. This is a function, students. This is a function and this is not a function. So let me just clear the ink. Okay. So f is a function. Why? Each value of x has only one value of y. And g is not a function. Same value of y has two different values of x. Let me just summarize this. Same y value cannot have two different x values. If you see this in a given relation, you must consider it as it is not a function. Inverse of this, students, inverse of this, that is fine. So for example, same x value, different x values. Okay, different x values can have same y values. If this is happening, then we can consider it as a function. If this is happening, we should not consider it as a function. Okay, we'll see some more examples further. Moving on to the next slide. Denoting relations. So how do we denote relations? Okay, so relations are denoted like this. A comma B epsilon R, or relations also can be denoted as A R B. So number 1 and number 2. Relations can be denoted in these two ways, students. So how do we read this and how do we read this? Both will be reading it in the same way. So how are we reading them, students? I'll just write down here. A is related to B. This is how we have to read it. A is related to B. A comma B belongs to R. How do we read it? A is related to B and A R B. Written like this. How do we read it? A is related to B. So this is how we denote the relations. Alright. Going on to the next one. Types of relations. So you know what is relations now, correct? Relations are nothing but set of ordered pairs. In that set of ordered pairs, same x value can have multiple y values. What is function? One x value should have only one y value. Just remember this much. This is the difference between relations and functions. So now there are some types of relations. So we'll just see only the types here. Okay, we'll get into the types in our next session. Alright. The very first type empty relation. So this is one of the kind of relations. Next one is universal relation. Next, trivial relations. So these both together are called as trivial relations. Moving on to the next one, reflexive relation, symmetric relation, and transitive relations. So these are the different types of relations. Okay. So we'll be seeing each one of them in our next session. For today, we'll be just stopping here. Once again, just summarizing, students, very important concept of mathematics, difference between relation and function. Okay, relation, one x value can have multiple y values. For example, 1, 7, 1, 8, 1, 9, 122, 100 also. See this. These are relations. X value is same. Different y values. Relations. What is function? One x value, one y value. For example, 1, 7, 4, 9, 6, 10. Each value of x has the unique value of y. These are called as functions. So this is just the summary, students. Alright. So we'll be continuing with the types of relations in our next class. So this session we'll be stopping it here. Thank you for watching this video. If you like it, please press the like button, share and subscribe. Thank you, students. I'll be seeing you in the next class again.